Hello guys, my name is Andrei, and this is a story of Monolith library which I rewrote into small modules. And in this talk, I'm going to show you what opportunities that opened up. In my previous life, I used to be a .NET developer. I wrote Silverlight, WPF applications, but they kept saying Silverlight gonna die, JavaScript will kill Silverlight. So I decided to check if it's true. I got this book, read it, and as an exercise, I created this graph drawing library. Graph as collection of vertices and edges. This graph here, it has 2000 vertices, 6000 edges. We can render something larger than that. This is 20,000 edges and 5,000 nodes, and it is really customizable. You can change lots of different arguments here. And the library itself is rendering agnostic, which means it can render using different technologies like WebGL or SVG or even CSS if your browser does not support SVG or WebGL. So needless to say, I never returned back to Silverlight development. But when I was doing this library, I reinvented a lot of wheels. For example, how do we normally structure our JavaScript applications? We have a collection of small files, then we concatenate those files together using tools like Grunt or Gulp or Cat to produce a release. And then we put this release somewhere into distribution folder, upload that to GitHub for everyone to use. And what we do inside of each file is really up to developers. Sometimes we wrap content of the files into immediately invoked function expression, pass context in that expression, and augment that context with our public API. If we are coming from a .NET or Java background, we try to mimic that with something similar to namespaces. But neither of these approaches is perfect. There are many problems. Scope is one of them. For example, if you forget to put an expression into function body here, and after we concatenate all those files, we'll end up being in a global scope here. Another huge problem is dependency resolution. For example, what if our library depends on some third-party library? What do we do? Do we include that into our bundle, or do we tell every developer to include that library into their HTML pages? And then we start to worry about the order of execution. So these are the problems which developers face during development of the library. But then how do users of the library use it? So they go to github.com, they download release, they included it into HTML file, then they start using it, and then they hope it will not break. They hope the dependencies are all satisfied and there is nothing else is overwritten in a way which shouldn't be overwritten. This library, VivaGraph itself, the way it is written right now, is 6,000 lines of code. It's really a large library, it offers a lot of functionality, and it's really huge. And that's actually another problem. What if someone needs to use just a small part of your library? Like this guy, he only wanted to use graph generators, but he didn't really care about visual aspect of the graph, how to render that graph. So what does he have to do? Well, copy-pasting just graph generators into his code does not make much sense. So it doesn't make sense to use entire 6,000 lines of code, right? And the solution to that is small modules and NPM. NPM stands for no prescribed meaning. Some people call it Node Package Manager, and what it does is it actually manages packages for Node. Each package in Node is just a collection of files. Usually JavaScript files in that package are written in a CommonJS format. In CommonJS, you clearly declare what your file exports, and if you need something, you just require that something. What's really nice about CommonJS is each file represents a scope. If you do not export something from your file, it remains hidden. No one will see that variables which are not exported from the file. This works really well in Node, but what do we have to do in the browser? And the answer to that is Browserify. You can think of Browserify as a smart concatenation tool which knows how to concatenate CommonJS modules and teaches the browser what is CommonJS. Let me actually give you an example here. So in this folder, we have index.js and food.js. Index.js requires food.js, and food.js just prints hello world to the console. So if you run this in Node, no surprises, hello world. Now, if you browserify this file, you see, we have concatenated bundle with all our functions and a small code over here which teaches the browser what is CommonJS. It teaches what is require, what is module, and what is exports. That's it. Very, very simple, very clever, very small. But after we do this, and let's say output result of browserified bundle into a file, then include this file into our HTML file here, like this. We can start using this in the browser. You see, hello world. So if someone needs to use just generators, what we do, we require a package which knows how to generate graphs. Then we create a grid graph 10 by 10 here, and in this example we just print number of nodes of that graph. So if you run this in Node, 100 nodes in 10 by 10 grid graph. If you open this in the browser, again 100 nodes, so code starts to be reusable in both platforms. So I started redoing my library into small modules. There is a separate module which knows how to construct a graph, how to add nodes to the graph, how to remove nodes from the graph, and nothing else. That's just its only responsibility. There is a separate module which knows how to construct Barnes hot tree to effectively simulate n-body forest problem. Oh, sorry, just n-body problem. And there is a separate module which knows how to integrate physical forces, how to work with physics. Now, composability is a huge part here. If you combine these three together into one package, you'll end up actually having a force-based graph layout module, which knows how to lay out graph in memory, but it doesn't really care about how you represent the graph on the screen. So for that, there is a separate module which you can use to render graphs with your favorite rendering library. Here's an example of fabric.js library which renders graphs in using fabric.js, very famous or very popular 2D drawing library. For example, this is a 10 by 10 grid here. You see it animates and wrap it here, and this is interactive. You can zoom in, zoom out using mouse wheel, and this is rendered by fabric.js itself. What's really nice is that this graph over here and these images here were created by exactly the same code. Fabric.js knows how to render images when you run it in Node.js. So just use that to render these images here and use it to render graph over here. Just amazing. And because everything is so abstracted, you can actually create a separate module which knows how to render graph in, for example, a terminal. So this module here, it renders graph using ASCII symbols. So we create a grid graph 10 by 10 here, and then we require that ASCII symbols rendering module, and then we just render it here. So if you run this in the terminal, you see it starts being like a 10 by 10 grid graph using just ASCII symbols. Or let's say change it to something more fun. Let's say path 100 nodes, and then just run this here, and you see it starts forming a shape of a path. Because everything is so abstracted, it is usually very easy to swap out different parts. So for example, in this example, I'm actually pretending in the browser that my browser is a terminal. So you can see a 10 by 10 grid graph rendered with ASCII symbols with the same module, but in the browser. So with this approach, you kind of become a yes man. If someone comes to you and asks to implement feature in your library, like this guy, he wanted to add support for Gephi files. Gephi is very popular open source graph analysis and drawing tool which is a desktop application. It is really nice tool, but with monolithic library, you would double think, do I really need to include this functionality to my library? Or maybe I don't need it. It's already 6,000 lines of code. Does everyone benefit from using that integration? With small modules, you just tell yes, you just create a new module and publish it, and you're done. Like here, I created this small module. I showed how to import files into Gephi or how to export files from the Gephi. And you just make people happy with this approach. Because everything is so abstracted. Like 3D is another amazing thing, but again, with a monolith library, you need to be careful about adding more stuff into it. With NPM modules, sure, you just create a new module which knows how to do 3D layout and just know how to render. For example, here is a basic example of rendering 3D graphs. There is a separate module which knows how to lay out graphs in memory in 3D space, and this one is using 3JS to render large graphs here. Like this is a 10 by 10 by 10 grid, render it in space. You can fly around here. Or this is in binary tree, perfect binary tree here, or just plain grid. Let's render something different, like a graph without any links, but which has 10,000, oh sorry, just 1,000 nodes. So it's like a small explosion. So you see all these different graphs, they're actually rendered by exactly the same code. Because you usually use modules, your code usually ends up being very, very small. Like this example which renders all these different graphs is really, really small. Like this is the entire source code for that. So what it does here, it just imports the query string module to parse query string arguments. Then it constructs graph from the query string, and again I'm using graph generators module here, and I'm just passing to that graph generators name of the graph and then how many nodes I need for that graph. And then I'm requiring a 3D renderer engine here, and then I just run it here. So 19 lines of code, very simple, very clear, like you can easily see what's the purpose of this module. Very simple. Composition again is really easy to do composition because I already had 2D visualization. Why can't I just combine it with 3D, right? So here is a 2D and 3D rendered side by side. It is a large graph here, but the layout is exactly the same. On the left is fabric.js rendering the graph, on the right is 3JS rendering the graph, and you see if you just drag one node, it starts flying over there, and the graph starts destroying itself, just a small animation. And very easy to compose pieces from different parts of the library. Really, really cool. So NPM, as it is right now, has more than 62,000 packages. Well, I thought, wouldn't it be cool to just see these entire packages visualized by this library itself? So here's an example. This is 62,000 packages visualized by this graph drawing library. Every blue dot is actually a package. You see, when I hover over a blue dot, it tells the name and tells how many dependencies that package have. And you can zoom in, zoom out from this graph using mouse wheel here. Like this is the larger picture of NPM universe part, and if we keep zooming out, you'll see a small ring of isolated packages forming like asteroid ring here. Let's zoom in a little bit here. So you can see in the middle are very popular packages like this one here. It's Lodash, one of the most popular packages on NPM. This is request, this is async, and this guy here is underscore. So if we keep zooming in here and see this gray area is actually all connection, all dependencies. We can zoom in here. It's a lot of dependencies, lots of modules here. So on the edges of this graph, there usually tends to be like namespace libraries, like this thing here. Look at the name. Everything starts with generator. Can you guess what the thing in the middle is? Yay! It's Yeoman generator. So This thing over here is everything related to Lodash. If we go somewhere else, like to this area, you see everything is related to Wiki. And ngraph itself, this graph drawing library, it forms a small group over here. So I always knew that in Node it is common to have tests, like people tries to cover their code with tests, and it's not surprising because with that many packages, if you want your package to be legit and if you want it to be noticeable, you have to cover it with tests, you have to have good documentation. It's just common practice. But I actually never saw how many packages were covered with tests. With this visualization, I thought I can easily do that. So here, you ready? If I click this highlight cover it with tests, it will show all packages covered with tests. It is 29,000 packages out of 62,000 packages. The good thing to Yaman, you see how they cover almost all of their packages with tests, so really nice. Almost half of the packages are covered with unit tests, which is really good. Now, you can also search packages over here. For example, if you search for Grunt, it will highlight all packages related to Grunt. So it's almost 2,000, almost 3,000 packages related to Grunt in the middle, and then there are lots of them out there. Let's search for Gulp. This is Gulp. What about Browserify? There we go. Not so many, but we can do something like regular expressions. Let's find everything what has IFI in it, and see it's almost 665,000. Oh, sorry, 665 packages. We can highlight like, let's say dot matches everything. Let's see. This is entire NPM universe. So this graph has almost 62,000 packages, and it's almost 120,000 edges here. Let's see, we can find everything what has just one letter name. So it's 33 packages, and you see all alphabet is actually taken. And this data over here, it's actually pre-computed. I wouldn't be able to lay out this graph at runtime, but because I already created all these npm modules, I could easily pre-compute layout of each of these nodes offline. It took me like 4 hours to calculate this layout, but I didn't have to do anything new. It's just exactly the same modules running in Node.js and computing this layout for me. So most likely when you will be watching this presentation, modules like 4 or 5 will be already taken. So with these many packages, you can actually use almost all of them with Browserify. Here is an example of Browserify dependencies itself. So you see Browserify is in the middle, and it depends on a lot of small modules. We can also switch to 3D view. And this is Browserify dependencies graph. So because everything is so small and modular, I also thought maybe it would be just nice and cool to export this graph into 3D model file. So I did that. I created a small module which exports graph into 3D model, and I sent that model file into a company in New Jersey called Shapeways. And just a couple weeks and $20 later, I got this in my mailbox. This is a 3D printed graph of Browserify dependencies. So this is graph here, this is the same graph, but this is like real graph, which like JavaScript escape from a browser. Recently I saw a tweet from someone saying, "Checkmate JavaScripters," and this guy was pointing to an answer of Eric Lippert, the guy who was a principal engineer of C#, VBScript, JScript, and Eric was arguing that it is really hard to write a large application, And it is specifically hard to do so using JavaScript, because JavaScript is dynamic type language. It does not offer that compiler support for developers. But then in exactly the same post, Eric argues that modularization, encapsulation, and code reuse are the ways to mitigate or fight that complexity. And this is exactly what NPM is about. Uh, NPM has everything modular. You can always hide your data using common JS file scopes. You don't have to export everything. And it is very easy to reuse this code base. You can find actually all of these examples you can find on my GitHub, and just feel free to check it out. Thank you very much. Hope you enjoyed this video. Let me know.